Imagine a restaurant kitchen where 50 cooks are trying to make 50 different meals on the exact same counter space. Ingredients are mixing, people are bumping shoulders, and one person's spilled soup ruins another person's salad. For a long time, this is exactly how building and running software worked. Multiple applications would be crammed onto a single server, all fighting for the same memory and processing power. It created a constant tangle. If one application needed a specific security update or a new piece of supporting software, installing it could easily interfere with completely unrelated programs sharing that server, causing them to crash. Because everything shared the same messy space, taking an application from a developer's laptop and moving it to a live server was incredibly fragile. Usually, something broke in transit. To fix this, developers realized they needed to stop sharing counter space. They needed to pack everything an application required into a perfectly isolated box. In the software world, this concept, a digital lunchbox for your code, is called a container. Inside this container goes the application's code, all of its required tools, and its exact settings. Once the lid is shut, it needs absolutely nothing from the outside world to function. Because it is totally sealed, you can take that container and move it anywhere. It will run exactly the same way on a cheap laptop as it will on a multi-million-dollar cloud server. By ensuring the environment travels with the code, containers finally solved the classic developer excuse of, well, it works on my machine. Now it works everywhere. Packing a single container is a great solution if you only have a few users hitting your website. But consider what happens when an app suddenly goes viral. You don't just need one container anymore. You might need 10 million of them deployed instantly to handle the incoming rush. No human operator can type fast enough to manually copy, paste, and wire up millions of software containers across thousands of servers. The operational risks pile up fast. If a physical server breaks down and drops a container, the app crashes for the user. On the flip side, if the viral crowd leaves and you forget to turn off those 10 million containers, you waste thousands of dollars an hour in server costs. We've moved past a local cooking problem. Managing containers at a global scale is a massive, high-speed logistics challenge. To solve that logistics challenge, you need software built specifically to manage other software. This automated management is called orchestration. Today, the system most people use for this is called Kubernetes, or K8s for short. Think of Kubernetes as a hyper-fast kitchen manager, or an automated traffic cop, built to oversee the entire system. It sits a level above the containers themselves. From up there, it constantly monitors the health of your physical hardware and watches the exact volume of incoming user traffic. If the container is the protective vehicle for your code, Kubernetes is the automated highway system guaranteeing every vehicle reaches its destination safely. To keep massive applications running smoothly, Kubernetes relies on 3 specific automated functions. First, when user demand spikes, Kubernetes scales the system up, instantly duplicating containers so the app doesn't freeze. Then, as demand drops, it deletes excess containers, saving money. Second is self-healing. If a server fails, Kubernetes instantly spins up a perfect replacement. The third function is load balancing. Like our traffic cop, Kubernetes routes incoming users evenly across all the available containers, ensuring no single digital line ever gets too long. By combining these 3 functions, the system guarantees that your application stays online and ready for users at all times, entirely without a human needing to step in. Next time you stream a movie or hail a rideshare during rush hour, think about the invisible traffic cop making it happen. The reason those apps don't crash when millions of people log on at exactly the same time is because this specific architecture is running behind the scenes. Modern cloud computing relies entirely on containers to pack the code perfectly and orchestrators to make sure those packages always deliver.